Rockets are some of the most complex engineering structures created by mankind. They are capable of overcoming the force of gravity and going into space. Today we will analyze how exactly a rocket flies, what forces act on it, and what stages it goes through during launch. A rocket usually consists of several main parts. 1. The booster stage, or first stage, is the main part of the rocket, which contains the engine and fuel to launch and raise the rocket to the desired altitude. 2. The second and subsequent stages. Depending on the type of rocket, there may be additional stages, each of which also has its own engines and fuel. They are turned on as the rocket reaches higher orbits or reaches the desired speed. 3. The body, the shell of the rocket, which protects it from external influences, such as aerodynamic drag and high temperatures at launch. Inside the body are fuel, engines, and other important elements. The engine, the mechanism that provides thrust to the rocket. A liquid or solid fuel engine is usually used. 5. The payload. This is what the rocket is intended for. This can be a satellite, a scientific instrument, equipment, or cargo that the rocket must deliver to orbit or into space. 6. Guidance system includes navigation and orientation systems that allow the rocket to accurately follow a given path and make trajectory adjustments. 7. Staging system. When the rocket reaches a certain altitude or speed, it jettisons the spent stages to reduce weight and improve flight efficiency. All of these parts work together to ensure that the rocket can successfully launch, reach the desired orbit, or complete its mission in space. Let's take a closer look at the rocket engine process. 1. Starting and fuel supply. A rocket engine uses fuel, liquid or solid, which is fed into the combustion chamber. For liquid rocket engines, this can be two components: an oxidizer, such as liquid oxygen, and a fuel, such as kerosene or hydrogen. In solid rocket engines, the fuel is already prepared as a mixture of oxidizer and fuel. 2. Combustion of fuel in the combustion chamber. The fuel burns in the combustion chamber, creating a chemical reaction. Combustion is the process by which the fuel reacts with the oxidizer, releasing a huge amount of energy in the form of heat. This results in the formation of hot gases with a high temperature, about 3,000 to 4,000 degrees Celsius. This energy is converted into kinetic energy of the gas molecules, increasing their speed. 3. Expansion and ejection of gases through the nozzle. Hot gases expand and move at a very high speed through the rocket nozzle. The nozzle is the narrow part through which the gases exit the engine. According to the law of conservation of momentum, when gases are ejected at high speed from the engine, an opposite force acts on the rocket, causing it to move forward: jet thrust. The process of expanding gases and ejecting them through the nozzle is also based on thermodynamic principles. Gases expanding lose temperature, but their speed increases. 4. Rocket lift and movement. The jet thrust created by the ejection of gases is opposite to the direction of their exit, and it is this that makes the rocket move in the air, or in space. This force overcomes the Earth's gravity and atmospheric resistance. Some of the fuel energy is used to accelerate the rocket, and the other is used to overcome air resistance in the atmosphere or gravity at launch. 5. Thrust and acceleration. As the rocket starts moving, its mass gradually decreases as the fuel is used up. This decrease in mass accelerates the rocket according to the principle F equals ma, where F is the force, m is the mass of the rocket, a is the acceleration, while the thrust force remains constant. Thus, the rocket accelerates with each passing moment as it becomes lighter, and at the same time, more and more energy is used to increase the speed. 6. Engine shutdown. When the fuel is exhausted, the rocket engine stops its operation. If the rocket reaches its target, it continues to move due to inertia, i.e., without additional thrust, until it enters the desired orbit or reaches its final destination. These processes are repeated in different variations, depending on the type of rocket, its purpose, and the fuel used. The main thing is that the rocket engine works due to the high speed of gas ejection and the reactive force, which leads to the movement of the rocket. Before launch, the rocket undergoes many checks: engine testing, fueling, checking all navigation and telemetry systems. Engineers carefully analyze the weather conditions, as strong winds or thunderstorms can affect the safety of the launch. A final inspection of the launch pad and removal of personnel from the risk zone are also carried out. Fueling a rocket is a complex process. The fuel used can be liquid or solid. Liquid rockets use cryogenic components such as liquid oxygen and hydrogen, which must be stored at extremely low temperatures. When it's time to lift off, the first stage's main engines fire, creating a powerful thrust that's strong enough to overcome gravity. The rocket rises, passing through several key layers of the atmosphere: the troposphere, stratosphere, and mesosphere. At this point, the rocket experiences enormous aerodynamic drag. The maximum load, max Q point, occurs when the air pressure is at its strongest on the rocket's body. Engineers calculate this point in advance so that the rocket can withstand the load without damage. When the first stage runs out of fuel, it is no longer needed and is discarded. In modern rockets, such as SpaceX's Falcon 9, this stage can be returned to Earth for reuse, significantly reducing the cost of launches. After the first stage separates, the rocket continues its journey using the second stage engines, which operate in the thin atmosphere and are designed to increase speed. The second stage continues to accelerate the rocket, providing sufficient orbital velocity, approximately 28,000 kilometers per hour. Once the required altitude and speed are reached, the second stage separates and the payload, satellites, cargo modules, or manned spacecraft, enters the designated orbit. Sometimes a third stage is used, especially on interplanetary missions, to provide additional acceleration. Once in orbit, the rocket either completes its task and its mission is over, or continues moving, for example, to the Moon or Mars. In this case, additional course corrections are required using maneuvering engines. Satellites can remain in orbit for decades, and spacecraft can be sent to other planets. This makes space technology incredibly important for science and research. Launching a rocket is a complex, multi-stage process in which every detail plays an important role. It is thanks to these technologies that we can study the universe, create communication satellites, and explore the far reaches of space. If you liked the video, give it a like and subscribe to the channel. In the next episodes, we will analyze how rocket engines work and what awaits us in the future of space flights.